In a previous lesson, we had an introduction to division of polynomials, in which we used long division of polynomials to perform the division. What we want to take a look at now is another type or another method that we can use to do division of polynomials. It's called synthetic division. So I've got a couple examples here that we want to work through to take a look at how synthetic division works and just be aware of specific things that are going on. Now, the type of synthetic division we're working on only works when you're dividing by a binomial, a linear binomial. If you're dividing by anything that's greater than a linear polynomial, like an x squared, x to the third term, you have to tweak the synthetic division method. So keep in mind that this only works when you're dividing by a linear term. So here's how we set it up. It starts getting set up similarly to long division, except underneath the division setup, we're only going to write down the coefficients of our dividend. So our dividend right here, I'm only going to write down the coefficients, not the variables. So 5, negative 32, that's negative 26, and 7. So those are the only terms that are going to go underneath the division sign. And then out front of the division sign, what I'm going to do is I'm going to take my divisor here of 5x plus 3. I'm going to set it equal to 0 and solve for x. So that's 5x equals negative 3, x equals negative 3 fifths. That's the number that's going to go out front here, negative 3 fifths. So we've got our dividend set up underneath, and we've got the term from our divisor set up out front. What I'm now going to do is I'm going to draw a line right here, leaving some space between the other numbers and that line. And the very first step that I'm going to do is I'm going to take the very first term underneath the division symbol and drop it down underneath this line. That's what you're going to do every single time with synthetic division. That very first move is to take that first number and drop it down. From here, it's a sequence of multiplications and additions, back and forth, back and forth. So here's how the process works. This number out front, the negative 3 fifths, is what you're going to multiply everything by. So here's how it's going to work. I'm going to do negative 3 fifths times 5, which is negative 3. That's what's going to go up here in the next column over. I'm then going to add negative 32 and negative 3 to get negative 35. So that's one cycle of multiplication of the negative 3 fifths times 5. It gives me negative 3, and then the addition. Now I do that multiplication division again. So multiply negative 3 fifths times negative 35. So doing that really quick, negative 3 fifths times negative 35. 5 and 35 goes to 1 and 7. So negative 3 and negative 7, that's going to be a positive 21. Positive 21 is what now goes up. So now I can add these two terms together. Negative 26 plus 21 gives me a negative 5. Very good. So now I start that multiplication addition cycle again. So it's this negative 3 fifths times negative 5, which produces positive 3. Produces positive 3, and that goes up here. And now I do another set of additions. 7 plus 3 is 10. Okay, so we worked our way through doing all the multiplication and additions. Here's how our solution works out. The first thing we need to do is all of these terms, except the very last one, except for the 10, need to be divided by the coefficient in front of the x in the divisor. In this case, it's a 5. So 5 divided by 5 is a 1. Negative 35 divided by 5 is a negative 7. Negative 5 divided by 5 is a negative 1, and the 10 just drops down. That last one just drops down. That's actually going to be the remainder of your solution. So here's how it works. Our dividend started with an x to the third. We're dividing out a linear term, which is just an x term. So that means our solution is going to start 1 degree less than our dividend. So our dividend started with an x to the third. Our solution here is going to start with an x squared. These numbers right down here are the coefficients in front of there. So our solution then becomes 1x squared minus 7x minus 1 plus my remainder of 10 divided by the dividend, or the divisor of 5x plus 3. And there's the solution to the division of the two polynomials. So these numbers that we calculated here become the coefficients in front of the variables, and then that last number is our remainder that gets divided by the divisor. So there we go. That's one example of synthetic division working through the setup and process of multiplication and addition. Let's go ahead and take a look at another example. Next example here, we've got 5x to the fourth minus 4x to the third plus 50x minus 37 divided by 5x minus 4. So, set up again, normal division sign. Again, the only numbers that go underneath are the coefficients. So in that case, it's the 5, negative 4. Now we've got to be careful here because there is no x squared term between the x to the third and the x. Just like long division, we have to have a placeholder. So we're going to put a 0 in there. Now I've got my 50, and last I've got my negative 37. So those are the numbers that go underneath the division sign. Now the number out front, 5x minus 4 equals 0, is what I have to do to calculate that. So I'm going to add 4 to both sides. That's 5x is equal to 4. Divide by 5. X is equal to 4 fifths. X is equal to 4 fifths. So that's the number. It's going to go out front here. There we go. Okay. Drawing my line down here. Just like the first problem, the very first step is to take your first coefficient underneath your division sign and drop it down. Now I can start my cycles of multiplication and addition. So 4 fifths times 5 is 4. And then I add. Negative 4 plus 4 is 0. Multiplication again. 4 fifths times 0 is 0. 0 plus 0 is 0. And then I do it again. 4 fifths times 0 is 0. 50 plus 0 is 50. Now we do my multiplication and addition cycle again. 4 fifths times 50 is 40. And then addition, negative 37 plus 40 is positive 3. Okay. So now that I've done my multiplication addition cycles, what I need to do now is I need to take and divide everything by the coefficient in front of the x of my divisor. That's going to be a 5 again. So divide by 5, that's 1. Divide by 5, still a 0. Divide by 5, still a 0. Divide by 5, that's a 10. And then I don't do anything to my remainder of 3. So that stays a 3. Good, so these are the coefficients in front of this variables of our solution. Again, our divisor started with an x to the fourth term, and we're dividing away an x term. So that means my solution is going to start with an x to the third. So that's 1x to the third plus 0x squared plus 0x plus 10 plus my remainder of 3 divided by my divisor of 5x minus 4. Now I don't need to keep all the terms that have zeros in them, so I'm going to rewrite this as x to the third plus 10 plus 3 divided by 5x minus 4. And there is another example of synthetic division. So what synthetic division essentially does for us is it eliminates having to work through all the variables in the process, and it streamlines and simplifies. You're still performing all the same work as long division, It's just a simplified process and a couple little steps to remember in order to make sure that the simplified process produces the result that we're looking for.